The goal of today's presentation is to talk about workload diversity and the dynamics that are changing and how we build out infrastructure and how we can do that in a flexible and meaningful way. But before we jump into that, I know we're coming back from lunch. Food's in there. We're kind of probably a little bit tired. And I thought I might make a little offer for everybody in the audience. Between Cisco and Ahead, we've set aside some resources and some funds to be able to provide UCS assessment services for any of the customers that are in attendance today. The thought process here is to sit down, work with your teams to better understand what kind of challenges you're facing in the data center, and then come back to you with a group and a section of recommendations, best practices that you can follow. And so if this is something you're interested in taking advantage, please find us at the Cisco booth upstairs or grab your local Ahead representative for some additional details. So throw out some interesting facts around the digitization of the world that we live in today. Almost everyone in the room probably has some type of wearable device on them. When you think about the data that a wearable device generates, it's almost 277 times the amount of data that you generate on a daily basis. But only a fraction of that ever makes it back to the data center. It's like a Boeing 787, which is generating 40 terabytes of data for every hour it's in the air, but only needs to return about a half a terabyte once it lands. By 2017, IDC says half the world will be connected to the internet. And by 2020, 5 terabytes of data will exist for every human on the planet. And that is a lot of 128 meg zip drives. So if you can do the math on that, just raise your hand and let me know how that all calculates out. But the point is that all these changes are happening so rapidly, and they drive a lot of change in the data center and ultimately, as Gene talked about this morning, how we work as an IT organization. And in 2014, this is when Gartner coined the term bimodal IT. Really, when you break it down, in mode 1, you're talking about traditional, reliable systems like a marathon runner, really focused on the bottom line of the business. But then, like we talked about this morning, on mode 2, it really relates to DevOps, these new application development type models. Like a sprinter focused on the top line of the business, delivering business outcomes. And this impacts the organizations that we work with in our customer base in a lot of different ways. Some are tangible. Things like an average mode 1 customer might have 80% of their infrastructure dedicated to production environments with only 20 focused on test and development. But when you get over into mode 2, it's the exact opposite, with 80% of the environment focused on test and development infrastructure and only 20% on that production environment. So how do we handle those types of shifts? It also impacts us in non-tangible, non-quantifiable ways. I was with a customer about 3 weeks ago. They're spending tens of millions of dollars to build out mode 2 capabilities. And when I asked them what the biggest driver was, the response surprised me a little bit in that they said, 7 years ago, they could go grab the latest and greatest, best talent out of any university they wanted to join their development staff. But that now is no longer the case, because those folks coming out of the university don't value being part of a big name firm nearly as much as they used to. They value the kind of tools and systems they get to work with on a daily basis. And at Cisco, our strategy is pretty simple. We're trying to help customers further optimize the mode 1 capabilities and be able to expand into mode 2 as easily as possible. And the application demands of the business put a ton of pressure on IT to move faster. That's certainly been a theme throughout the day. And to move faster, we need to be able to deploy and redeploy assets and really increase our automation capabilities and do so regardless of where a workload happens to exist. And at the same time, while this move faster dynamic is going on, we also need to be able to handle these different types of workloads. It's not enough anymore just to be able to virtualize an application server and send it off somewhere. It's not providing any kind of competitive advantage to the business. The business would like to see us provide scale-out systems, in-memory analytics, different types of architectures of underlying infrastructure than what we've had to support in recent years. And then when you look at the Internet of Things, it really starts to blur the lines on where data is going to be collected and where it's going to be processed. And so if we take this mode 1 and mode 2 concept and put all the compute options on a big spectrum, it probably looks something like this, where I have on the left side hyperconverged and converged solutions trying to add that easy button, make it easier to operationally get resources deployed within my environment. On the right side in mode 2, this is the side where we're aligning with these DevOps models. We're trying to allow the business to be able to tell their customers how they want to deliver value and then take that and deliver it all the way through the value chain. Really, this is where the business can begin to orchestrate IT versus IT orchestrating itself for the business. And in the middle, we have these form factors, blade servers, rack servers. They could really be used in mode 1 or mode 2 operations, depending on whatever the particular use case is. Now, how many folks in the audience have set a standard on rack servers, blade servers, anything like that? And how many people are here? There's probably a bunch of people upstairs at the hyperconverged session right now. And what we're seeing is customers obviously continuing to want to select and probably end up with some type of a situation like this. And what's interesting about all these choices we just talked about is that they're coming at us faster and faster. So it used to take the applications, I don't know, every 10 or 12 years to go from a mainframe change to a Unix change, these big architectural shifts in the data center. Now it's taking every 18 to 24 months. And with software-defined storage, network functions, virtualization, we can ramble off 4 or 5 more acronyms, and all of a sudden you realize these different types of architectures in the data center are just, again, coming at us really quickly. So what we need to be able to do is handle that pace of change and be able to, in a meaningful and impactful way to our organization, make the decisions on what kinds of these new technologies do we want to adopt and how do we operationalize them in an effective manner. And if we think back to how virtualization entered the data center in the first place, we had these freestanding infrastructures, which really, the goal was not only to optimize resource utilization, but we forget that we had these silos of x86 compute resources, where I had a particular server configured a particular way for a particular application. Virtualization helped flatten those pools out, and it was a really big part of that value proposition. And we built these environments out of network, compute, centralized storage in an a la carte kind of fashion, put it together, and consolidated and virtualized very successfully as an industry. Then from there, we did such a good job, we wanted to be able to take on business-critical applications with higher levels of reliability for these types of environments. And this is where integrated infrastructure, converged infrastructure was really born. The thought here is to lower the time to value for the business and the investments they're making so you can deploy faster, but also deploy in a fashion that is more reliable than maybe when you're doing everything on your own in the past. We're seeing the rise of a lot of hyperconverged solutions as well, which promise to take that operational simplicity a step further. Now, it's a little bit of a departure because we're getting away from that centralized storage array, we're including that in the server, and we're building out a pure appliance model. Now, with that pure appliance model, there are some challenges in terms of scalability, performance, some feature sets, but either way you look at it, integrated infrastructure, hyperconverged infrastructure, are going to continue to grow at a rapid pace over the next 3 to 5 years. And then we have customers with decisions around scale out. How do we handle these big data and analytics environments, these bare metal environments that scale not in the tens of nodes, but in the hundreds or thousands of nodes? And this is where the application provides all the resiliency, and the hardware itself can be simplified underneath in order to meet that need and optimize ourselves for that particular use case. And the point is 2 things here, really. Logically, it makes sense how we got here. Additionally, there's reasons for our customers and everyone in the room to probably need to be able to support freestanding infrastructure, integrated infrastructure. It doesn't matter. There's good reasons for you to want to be able to use some, if not all of them. But the problem gets to be, we have to ask ourselves as we take on all these different types of infrastructure, are we creating a data center that's going to be a nightmare or some kind of a nirvana? And I think the goal is nirvana, but we're also seeing this kind of a phenomenon. I don't know if this looks familiar to anybody in the room right now, but as we go from, as an industry, looking at, say, a server or an individual component as the level of what we are considering a resource, and we take that up to a stack level, we really run the risk of doing this, which is inserting those resource silos back into the data center. Remember, this is against the goals of what we were trying to do when we started virtualizing and building out these types of application footprints in the first place. In this particular example, I have a scale-out environment that's running low on resources, but I'm unable to get resources that I have sitting idle in my freestanding infrastructure or integrated infrastructure over to my scale-out environment. And not only does this impact you in operational ways, but it's also a people problem. The customers always describe to us they're trying to expand their people's capabilities and broaden their knowledge and tool sets. However, if you think about this and all the other types of infrastructures you might take on, that becomes really challenging if you're going to have a group that's great at deploying a scale-out environment and a second group that's great at handling their converged infrastructure, for example. And financially, this represents that technical debt that Gene talked about this morning, or a tax on every dollar that you would spend in investments you make inside of IT, because I have unutilized resources or underutilized resources. Does this resonate with folks in the audience? Okay. So the bottom line is what we would like to be able to do is to take all these different kinds and other ones right around the corner and be able to deploy them and represent them as a policy inside of one system and one type of operating model. So that way, we don't care what kind of infrastructure you need to deploy or what kind of application the infrastructure or application dictates. We can simply give you the bare metal that you need to start building out XYZ use case of choice. And this is really was the goal of UCS when we launched the system in 2009. We took an object-based, policy-defined approach that's really expanded throughout the entire data center portfolio at this point. So you'll hear the terms about ACI, SDN. That policy-defined team that put together those product sets are the same folks that created UCS. And so this is an important part of the strategy. And also, it's not just about the data center. It's about, can we take these capabilities and help you deliver them out at the edge, where, again, we're seeing a major demand and rise in compute resources required. Can we help you take and give you the workload mobility you require to get your workloads out to the cloud? So let's take a look at how this all comes together, because it's never as simple as one might want once you start pulling the covers off of the individual pieces. So we talked earlier about individual element management. It's not uncommon for a customer to have 6, 7 types of element managers that they need, because you might have 2 storage platforms, 2 networking platforms, 2 compute platforms, etc. So if we think about that in terms of this example, the next thing we are going to do after we have element management is layer in automation. And it's at this point where you start asking yourself, am I operating in a mode 1 environment or am I operating in a mode 2 environment? What kind of tools am I going to pick for automation? And then how does that impact the decisions I'm going to make upstream as I look at cloud? This is a little bit of a reverse of the story sometimes that you hear from vendors, which would come from the cloud angle and say, from everything up here, everything looks good. Use anything underneath me you want. But if we think about all that element management at the bottom of this stack, this is where a lot of that complexity challenge comes in. If we take a system like UCS that allows you to manage those compute network and storage resources at that stack level as opposed to the individual component level, it really is providing you with a policy-driven infrastructure, an open API for the infrastructure, not just for the compute layer. And this can be incredibly useful as you build out this scenario a little further. So we layer in a couple of automation tools. Perhaps you choose System Center for Microsoft because you leverage a lot of Microsoft. That's a good mode 1 decision. And then for whatever reason, you're looking at Splunk to analyze data in new and interesting ways as a mode 2 tool. Perfectly acceptable decision. So now you have 2 automation tools that need to be integrated with just your one policy-defined infrastructure. Add in cloud. Probably not going to have just one cloud platform. Maybe it makes sense to leverage Azure because you're already leveraging System Center and there's tight integration there. So that's your mode 1 choice. But in mode 2, maybe you're looking to do something interesting with OpenStack. And so with that, now you have 2 cloud platforms times 2 automation platforms back to just 1 policy-driven API for the infrastructure. Think back to all the combinations and permutations we talked about earlier. If I have 6 element managers sitting there, that math gets really ugly because I have 2 cloud platforms times 2 automation tools times 6 different element management. That's 24 different management paradigms that you have to somehow keep alive and running. This really affects our ability to be able to deliver with speed and deliver in a flexible manner. And that's why this policy-driven infrastructure concept is so important, not only to UCS, but to the broader data center strategy within Cisco. There we go. And this is really the goal. We want to be able to take and provide you with one operating environment, regardless of the type of infrastructure underneath it, whether it's in the edge with a UCS mini type solution that we launched in November, or whether it's all the way through a converged infrastructure solution like VCE, where we've been an industry leader, or over to the hyperconverged space. We'll talk a little bit about more of that later. It's really all about delivering speed and simplicity, regardless of the type of workload. And to give you a little bit of a different view on that, let's think about UCS management in this context. It was mentioned earlier in the earlier session that a UCS director and a UCS management suite can manage things that don't just say UCS. So I want to be very clear on that. We label everything UCS, but that doesn't mean that we only work with our compute platform. In fact, if you look at it from a Cisco converged infrastructure standpoint, UCS is in the middle of almost 70% of the market of converged infrastructure, and there's plenty of customers that we can introduce you to who absolutely love how we provision storage within these tool sets that we have available as part of that UCS management ecosystem. We're taking a similar approach to hyperconverged, where we have an ecosystem of partners who believe that we can help them more effectively deploy their hardware, or our hardware, with their software stack. And we're building these one-button infrastructure type deployment models. With HDFS, with Hortonworks, we launched something called UCS Express, which is basically a one-button deployment model to help push out as many nodes as you would like to of Hortonworks. And we're continuing to go down the line with other open source providers and provide the similar functionality so that if you need to deploy a converged infrastructure stack, great. Hyperconverged, fantastic. You can make those decisions, and we can support you from the same and consistent manner. We've talked a lot about the data center, but obviously that doesn't happen in a vacuum. And particularly when you start talking about mode 2 capabilities and being able to deliver things to the cloud becomes increasingly important. And so Intercloud Fabric is something that we're delivering to really securely not only allow you to have choice as to where you want to extend your workload, but also to be able to bring that workload back within your data center in a really, really flexible way. And that is something that if you have not had a chance to see, it's a 30-minute session on its own, but it's really matured over the last year and is a fantastic solution. And then from an edge standpoint, I mentioned UCS Mini earlier. This really has 2 use cases. One is remote office, branch office, like we talked about, being able to take all that data center functionality, shrink it down, and put it out inside your bank branch, et cetera. And the other one is small-scale IT. So there's a lot of customers that didn't need to have compute domains scaling in the hundreds of servers like we offered with UCS out of the box. But this allows them to take advantage of that same exact operational model and enterprise quality hardware, even though they might only need to expand to 15 or so servers. The next one we'll talk about is M-Series. I'm sorry, there's no time up here that I see. But, excuse me for that. 137, perfect. So with M-Series, we're actually changing up how we do compute. This is a product that we take to the cloud scale. And cloud scale environments that are scaling to these thousands of nodes, we need to be able to effectively change the game instead of just making customers add rack mount servers all the time. So when you add a rack mount server, you're also adding hard drives, fans, additional connectivity to the network, power supplies, stuff that, frankly, you don't really care about wanting to add, and stuff that when you go to refresh that server 3 years later, you take out the 1U box, you put this box in, and guess what? You replaced all that stuff you didn't want to buy in the first place again. So what we did was we actually drove big innovation here. It's referred to as system link technology, but allows us to actually truly disaggregate the memory and CPU from the rest of the subsystems of the compute node. Effectively, what you end up with is, in the back of the system, you have these shared resources that you see represented in blue that we talked about, compute, hard drive, network connectivity, et cetera. And at the front, all that's remaining is your CPU and your memory. So that little cartridge on front, you can walk right down, pull those in and out, swap them out, and you've done a whole compute refresh without having to not only deal with the operational headache of replacing all those rack mount servers, but you've also not had to buy all those parts again. So that's another one to take a look at. Okay. So really, as we end up wrapping up here, I want to make sure that we understand and we work with customers on a daily basis who frankly evaluate Cisco solutions and the value we're bringing to the market in the same way that the business evaluates them as an IT organization. And that's, can we deliver with speed? Can we deliver things in a flexible manner that allows our customers to do more with less? And can we deliver in a very secure and reliable fashion? And when you look at the TCO numbers that are up there, we've been saving a tremendous amount of time and money for the 43,000 UCS customers we've amassed over the last 6 years. And really, what we want to do in terms of this assessment that I mentioned earlier, since I know there's some folks in the room now that have joined us, we're offering the opportunity for us to bring in our experts to sit down with you to figure out exactly what those numbers would look like for you from a TCO standpoint, and also understand what you're trying to accomplish as a business and how can Cisco Data Center Portfolio and Ahead and Cisco work together with you to help get you from point A to point B.